When we begin looking at the domain of a function, it's important first to get a definition or an idea of what domain is. For us, we're going to refer to domain as the set of all input values. In other words, I need to list out every single number that I'm allowed to plug into the function. Normally, these are my x's. At the same time, we'll talk about domain restrictions, which are numbers that can't be put into the function. And it can't be put into the function for a variety of reasons. We're going to talk mainly about different types of domain restrictions down below. And the key is that sometimes I'm going to talk about domain, sometimes I'm going to talk about domain restrictions, but I'm really getting at the same idea. I might talk about the numbers I can have, or I might talk about the numbers I can't have, but it means the same thing. So our first set of domain restrictions are going to come from division by zero. We know that we can't divide by zero, so if we have a fraction, what we need to do is set the denominator equal to 0 and solve. And specifically, I'm going to talk about restrictions, what we can't have. And since we can't have division by 0, we're going to say that we set it not equal to 0 and solve. Same idea, it's just a difference of the terminology of what we're using. So if I look at example 1 here, when I look at the first one, the x minus 16 on top, he doesn't give me any sort of domain restrictions because he's not giving me division by 0. He's not in a denominator. So the only piece I really need to look at is that x plus 4. And I know that he cannot equal 0. Every other number's fine, but x plus 4 can't be 0, which if I solve that, x cannot equal negative 4. So that's one way of talking about my domain. I can say x is not negative 4. That's a domain restriction. If I look at it in terms of a number line, this might seem a little ridiculous now, but it'll be important later. That means I have a missing value at negative 4, but I have everything else in my domain. So if I want to state the domain instead of the domain restrictions, my domain is going to be everything I can have. Negative infinity to negative 4, union negative 4 to infinity. So that's just another way of looking at this, talking about either what we can have or what we can't have. Domain restrictions and domain. For number 2, again, we're not really worried about the numerator right now. He doesn't factor, so nothing's going to reduce. So I'm just worried about the denominator, and it says set it not equal to 0. And when I do that, really what I'm just doing is setting each individual piece not equal to 0 by using the 0 product property. So I have x minus 7 isn't 0, and x plus 8 cannot be 0. So I can see that I have x is not 7 if I add them over, or negative 8. Those are my domain restrictions. Those are what I'm not allowed to have in my function. If I think about it in terms of a number line, I have open dots or open circles at those two values, but I include everything else in my function. So if I want to write out the actual domain using interval notation, I have everything from negative infinity to negative 8, union negative 8 to 7, union 7 to infinity. It's a little more cumbersome to use the interval notation in this case, so I would probably use the domain restrictions, but later on we'll need the interval notation, so I'm going to talk about it now. For number 3, the last example of division by 0, the negative out front doesn't really matter to me because that's not division by 0. The 3 up top doesn't really matter to me because that's not division by 0. All I really care about is this bottom right here, and saying he can't equal 0. But it's not too helpful the way it is. I want to make it look something more like that form right there, a factored form. So I know that I can split him in half and try factor by grouping. So I still have the negative out front, along with the 3 on top. Factor by grouping says that I can pull out an x squared. And I get a 3x plus 1. And then I want a 3x plus 1 out of the second set. So pull out a negative 25, and that gives me 3x plus 1. So my factored form, hopefully we can see this. I have x squared minus 25, which is x minus 5, x plus 5. That's a difference of squares. And I have 3x plus 1. I just skipped one step there where I did the combination of the grouping and made the x squared minus the 25 into the difference of squares that it is. So if I get my domain restrictions, x is not going to be 5 or negative 5 or negative 1/3. I said each of the pieces not equal to 0. Now, you can just leave the restrictions in this case. That would be much simpler. If you feel like really writing out the interval notation, it'd be negative infinity to negative 5 union negative 5 to negative 1/3 union negative 1/3 to 5 union 5 to infinity. You could do that if you want, but I'm going to stick with the restrictions in this case. So division by 0, if I have any sort of variable in my denominator, I have to make sure the bottom doesn't equal 0. That's my first set of domain restrictions. My second set of domain restrictions is a negative underneath an even index. By even index, I mean square root, fourth root, sixth root, etc., etc. So if I end up with variables underneath an even index, what I have to do in order to ensure they're positive is set what we call the radicand greater than or equal to 0. By radicand, I just mean stuff under the square root or the even index. So if I'm looking at number 4, notice there's no possibility of division by 0 because there's no division, so I don't have to worry about that type of domain restriction. But I do have an even index here with a square root, so I have to ensure that the x plus 6 is 0 or above. We're not going to deal with i's or imaginary numbers here. So that means x has to be negative 6 or above. Notice how now I'm going right to my domain. I'm not worrying about the restrictions, so I get the domain out of it. If I think about a little number line, closed dot, and going up, notice the difference here. When I have any sort of square root or even index, it actually chops off part of my number line. With the division by 0, I would get just some sort of hole in the graph, one missing value. But when I have a square root or an even index, it actually cuts off my number line and throws some of it away. That's going to be important once we start going backwards or combining these together. So I could also write this as negative 6 to infinity if I wanted to write interval notation. Doesn't really matter here which one you write. One's as good as the other. For my second example, I need to look at what's going to give me a domain restriction. I have no division, so I can't divide by 0. I do have a radical. It's an even index with the 4 right there. So all I have to worry about is that stuff underneath, the radicand. Whatever's chilling out front is not going to give me any sort of domain restriction. I only have to look at the radicand. So I take the 5 minus 3x, ensure that he's positive, greater than or equal to 0. And then I subtract the 5, so negative 3x, greater than or equal to negative 5. Divide by negative 3. Be a little bit careful. Flip the sign, 5/3. When I divide by that negative, I need to flip the direction of the sign. So x is less than or equal to 5/3. Little number line, there's 5/3. Closed dot, going that way. Again, the key is realizing that I'm chopping off part of my number line. Anything above that 5/3 is not in my domain. I could also write this as negative infinity to 5/3 bracket. That would be the interval notation. Either one is fine. So there's my second example of a negative underneath some sort of even index. I need to make sure that it's not negative. Example 6, it's real easy to jump right in and say, oh, he's got to be greater than or equal to 0 because I see some sort of radical sign. But make sure that you pause and look really carefully because my index is odd. It's not an even index. So since the index is odd, there are no domain restrictions. Notice how there's no division either, so I can't have division by 0. So my domain is just going to be negative infinity to infinity. If there's no restrictions, I have everything. So those are my two basic ways of getting a domain restriction: a negative underneath an even index and division by 0. In the next set of examples, we're going to go through and combine those two together, and then also look at some functions that have no domain restrictions.